Okay, so in today's class, we'll be speaking on fundamental and derived quantities. Now, this is physics for 2027 Jambites. Now, when we speak on fundamental and derived quantities, we're actually speaking of mass, length, and time. Although we have 7 main fundamental quantities, but the major is mass, length, and time. Now, what are fundamental quantities? Fundamental quantities, they are those quantities that stand alone. They are not dependent of other quantities. In fact, other quantities need fundamental quantities. Derived quantities is a combination of 2 or more fundamental quantities. So the 7 fundamental quantities we have is mass, length, time, electric current, luminous intensity, number of moles, and temperature. Now, these are quantities that stand alone. So we'll be taking them one after the other. First of all, we have mass. The amount of substance present in the body. Now, what are the major things you need to know concerning mass? First of all, you need to know mass is measured in kg. This is the standard SI unit. The measurement of these quantities is known as SI units, systemic international units. You get? So we have mass to be kg, we have length to be meter, we have time to be seconds, we have temperature to be Kelvin or degrees Celsius, we have luminous intensity to be candela, we have number of moles, N, to be mole, measure the mole. These are just their SI units. You understand? We have electric current to be measured in ampere. You understand? So the major fundamental quantities: mass, length, temperature, time, electric current, luminous intensity, number of moles, and these are their SI units. Now, although those are their SI units, we also have different SI units for them also. In mass, we have kg to be the standard SI unit, but we also have something like gram, because even kg itself, it's kilo. K is known as kilo, which is 1000. You understand? So it is like 1000 gram. So gram is also an SI unit of mass. Now we have length. Length can also be cm, mm. You know the major thing. The major thing is just know this stuff, because if you check, c here is known as centi, and m is known as milli, and milli is 1 times 10 raised to power minus 3. So all these are just like constant values placed in front of the actual SI unit. You understand? So when we speak of time is measured in seconds, hours. Time can also be measured in minutes. How do you convert? Let's look at conversions. Imagine you are given a problem that has to do with 1 kg, and they ask you to convert to grams. What do you need to do? First of all, know the fact that k here means kilo. That's 1 kilo. K there means kilo, and 1 kilo is equal to 1000. So you have something like 1 times 1000 is equals to 1000 grams. So this is the answer. So if you are converting from gram to kg, you divide by 1000. That is, if you are converting 1000 gram to kg, it will be 1000 over 1000, which will give you 1 kg, just like what we had there. Now, if we have to do this for time, then we have seconds to be the original. I know in that song, 60 seconds make 1 minute. 60 minutes makes 1 hour. 24 hours makes 1 day. Then you do the rest by yourself. You know those ones. Now, if you are given a question where you have, let's say, 60 minutes, and they ask you to convert to seconds, it is very, very easy. Just know that 1 minute is equal to 60 seconds. So you have 60 times 60 equal 3,600 seconds. You understand? So this is 3,600 seconds. So if they ask you to convert like 1 hour to second, or let me use 2. If they ask you to convert 2 hours to seconds, you have something like 2 times from these 2 hours, 2 minutes, 2 seconds, and this one is like 60, 60, 60. You understand? So 60 times 60, 2 times 60 times 60 will give you 7,200 seconds. So for us to like get from hours to seconds, we have to multiply 2 times 60 times 60 to give us 7,200 seconds. Now, this is not where the actual problem is. The actual problem is when you talk about derived quantities. So when we talk about derived quantities, we need to know the meaning. What's the meaning of derived quantities? Now, 2 or more fundamental quantities mental quantities produces a derived quantity. TT. 2 or more fundamental quantity will produce a derived quantity. Now, for example, like for a derived quantity, let's take velocity as an example. Velocity has a formula. Velocity is equal to change in displacement over time. That's change in time. Change in displacement over change in time. Now, what do we need to do? First of all, we need to get under the length family. Under the length family, we have displacement, we have distance. Under the length family, we have displacement, we have distance, we have height, we have extension, we have breadth, we have width, and every other thing. Now, since they are under the length family, they will carry the length SI unit, and you know that of the length from what we said is meters. So this stuff here now is measured in meters. You understand? Now this guy is time, and time is measured in seconds, and now you have the operation to be division. So you can say this is meter per second. So velocity is measured in meter per second, and because it is not just only one fundamental quantity we have here, this velocity is known as a derived quantity. You understand? So let's do for acceleration. No, let's do for the acceleration is to it's not complex, but I will explain that part. Let's do for area. Let's do the simplest part now. We have length times breadth. We have length times breadth. Now, breadth. Now, if you come to this part, you have length is measured in meter times breadth is also like a part of length measured in meter. So m times m mathematically will give you m squared. So this is not a derived quantity because it consists of 2 or more fundamental quantities. You understand? So derived quantities are those quantities that can't stand alone. They are dependent on the fundamental quantities. So example of those quantities are on the screen. You have length, you have area, volume, you have density, we have force, we have work, we have energy. All those are known as derived quantities. Now, so if I should ask, what is the fundamental quantity? Sorry, what is the SI unit of force? What is the SI unit of force? Now, we have force to be equal to mass times acceleration. Now, this is a complex formula because why? This guy now is a fundamental quantity, but acceleration is not a fundamental quantity. Now, what do we need to do when you get there? Not distress yourself. Make this guy broken down, break this guy down and put it in a term that when the formula gets to a point where the formula only consists of fundamental quantities. So you have something like acceleration here is equal to change in velocity over change in time, and velocity, we know velocity is equal to m over s. So we have something like m over s, then time over s. You understand? So this is m over s over s. Now if you want to do something like that, is just add over 1 down here. This is what I used to do. So you have m over s divided by s over 1. It's still the same thing. You understand? So you have m over s times 1 over s, because you are since you are changing them, this guy numerator down to denominator and this guy to numerator, the sign changes from division to multiplication. So you have something like m times 1 m, s times s over s squared. So the SI unit of acceleration is meter per second squared. You understand? So you have force to be equal to, mass is measured in kg times meter per second squared. So you have something like kg meter per second squared. But if a genius will not write it this way, the genius will write it like kg meter per second square. So this everything here is also known as Newton. So force is measured in kg meter per second square, or force is measured in Newton. So this is all you need to know concerning fundamental and derived quantities, not to talk on their measurements. So I'll give you some work to do, and then I won't attach the answers. I'll give you the work to do, and then you comment the answers in the comment section. Thank you.